Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about how to factor and solve quadratics when the value of a is going to, the absolute value of a is greater than 1. Right, when we solve and factor when the absolute value of a in a quadratic is greater than 1, we're going to go through the similar process that we went through when a is equal to 1. So remember from the prior lesson, we have the first two steps. The first step is to take out the common factors, use a distributive property and take those common factors and put them outside of the quadratic in parentheses. The second step is to look for common product patterns, so the difference of two squares or perfect square trinomial. The third step is similar to what we did with factoring when a is equal to 1. We're going to use the diamond and square process. Now you can also do this in your head if you're really good at factoring. I don't require my students to do this, to factor this way, but I give this to them as a process in order to figure out the factors of any quadratic. So this time in the diamond and box, in the diamond we're going to place, instead of placing c on top, we're going to place the product of a and c on the top, and then we're going to place b on the bottom. So remember, b for bottom, b goes on the bottom. Previously, when a was equal to 1, we just put c on the top. But now that we have a as a value that's greater than 1, then we're going to put a times c on top. So we take a look at the example that I've given to you, 2x squared plus 7x plus 3. And I take the product of a and c, which is 2 times 3 or 6, on the top of the diamond, and then b, which is going to be 7, and I put that on the bottom of the diamond. Now what I want to do is I want to look for the factors of 6 that add to 7. So the factors of a times c that add to 7, and typically you're going to have to list those out, or you can do those in your head, but they're 1 and 6, minus 1 and minus 6, 2 and 3, and minus 2 and minus 3. So out of these, the only one that sums to 7 is going to be 1 and 6. So I place the 6 or the 1 in the left and right hand side of the diamond. And now we're going to move on to the next step, or continue with the next step. So I have 6 again on top, that's the a times c value. Then I have b, the b value on the bottom, the factors of a times c that add to 7. And we're going to take those values and we're going to place them in our box. So in this case now I have the first term. So the first term in the upper left hand corner is always going to be the first term. So I have 2x squared. And then in the bottom right hand corner I always have the c value. So the first term and the c value, this is consistent with what we did last time when we factored using diamond and boxes. In the lower left hand corner I'm going to put the value on the left hand side of the diamond. Upper right hand corner I'm going to put the value in the right hand side of the diamond. So I have 2x squared, x, 6x, and 3. And I'm going to go through the same process I did previously where I'm going to take the common factor from the columns and rows. So I take the common factor of 2x squared and 6x. That common factor is 2x. I take the common factor of x and 3. That's going to be plus 1. Then in the rows I take the common factor of 2x squared and x. That's going to be x. And then in the second row I take the common factor of 6x and 3. That's going to be plus 3. So now I end up with my solution, which is 2x plus 1 times x plus 3, and that's my factor. Now I haven't solved the equation yet because there's really nothing to solve at this point. I've given the factors. Now if I were to set the equation equal to 0, okay, so I wanted to find the x-intercepts now. I wanted to find the roots of the equation. Now I can use the factor to solve for x. So remembering the zero product property that anything times 0 is equal to 0, either this first term is 0 or the second term needs to be 0 in order for the equation, the factors on the left hand side to equal 0, or to multiply out to equal 0. So that means 2x plus 1 needs to be 0, or x plus 3 needs to be 0. And 2x plus 1 is 0 when x is equal to negative 1/2. And x plus 3 is equal to 0 when x is equal to negative 3. So if I asked you to solve for x in this case, when the quadratic is equal to 0, you'd provide me with the answer x is equal to negative 1/2 or negative 3. If I asked you to factor, then you would end up providing me with the answer 2x plus 1 times x plus 3. Now remember, sometimes you might need to use a quadratic formula, so I put it in here for your information only. And the quadratic formula provides us with the values of the x value for the x-intercept. And that's going to be minus b, or the roots of the equation, minus b plus or minus the square root of b squared minus 4ac over 2a. So minus b plus or minus the square root of b squared minus 4ac over 2a.